Okay, so let's take a look at this one here. You have the infinite series. Now, sometimes what they'll do with infinite series is they'll actually drop off the limits and just write series. So this, of course, can't be defined at zero, so it would have to be a series starting at least at one, if not, and it could start any higher, at higher values as well. So this doesn't have to be zero to infinity because we're not talking about what it converges to, just uh, will it converge. So we're looking at the tail end of the series to see if it'll converge. So sometimes you'll have these written, they won't give you the index variables limits. Uh, just understand that when you see it without anything written, that does mean we're talking about an infinite series. So it is going to infinity, we're just not told where it starts. But that's okay, because we know it's infinite series, and so we want to test convergence. Now, this one here, we could use the ratio test, but just to review, I want to do this with the root test. And it kind of stands out as a good idea for the root test because I have a 2 to the k and an x minus 3 to the k. Yeah, I am going to have to deal with the root of k, but we'll handle that in a moment. So I just want to do the root test as another option. You could also try the ratio test here uh, as well. The results should be consistent. So the root test, remember, what we do is we're going to look the limit as k goes to infinity of the kth root of the absolute value of all this stuff. Now, when I apply absolute value, I'm going to be kind of a little liberal here. 2 to the k is always going to be positive, so I'll just go ahead and write 2 to the k. K is always going to be positive, so I'm going to go ahead and just write k. The x minus 3 may not, so that'll be absolute value of x minus 3 raised to the k power. Okay, so we go ahead and apply our kth root. Limit as k goes to infinity of kth root of 2 to the k, which would be 2. Kth root of absolute value of x minus 3 to the k would just be absolute value of x minus 3. And then in the bottom, we're going to have kth root of k. Now, we actually did this a while back in an example, so just to save us a little bit of writing and a little bit of work time here, kth root of k is equal to 1. We actually did this in an example a while back when we first started looking at the root test. So back in 10.7, we actually did an example where we did the kth root of k. Let me see if I can find that real quick here for you. We did do it in a problem. I think it was with our initial examples with the root test. Okay, we actually did 2 over k, I think, instead of this was k squared to the k. So instead of 1 over k, we did it as 2 over k. But it should follow a very similar process for kth root of k. So that's k to the 1 over k. It's going to follow very similarly to what we did here, so that we eventually get that limit is 1. That limit is 1. Okay, so it should be a very similar process there. So we're just going to take that as a given that is 1. So that means our limit as k goes to infinity of this stuff, actually I don't need to write limit anymore, will be 2 absolute value of x minus 3 all over 1. So that'll be 2 absolute value of x minus 3. So that's what's going to happen when we take the limit. And now for this to converge, this stuff needs to be less than 1. This thing needs to be less than 1. So working with that, I can get absolute value of x minus 3. Bring the 2 over. It's less than 1/2. That would mean that x minus 3, since it's less than that, will either be smaller than 1/2 or bigger than a negative 1/2. And then we add 3 to both sides to solve for x. So negative 1/2 plus 3 will be 2.5 or 5/2 less than x, and 3.5 will be 7/2. So we're somewhere between 5/2 and 7/2. Okay. So then we need to test the endpoints. Okay. So we need to test, does it converge at 5/2? Does it converge at 7/2? So what we've found basically here at this point is that it's somewhere between 5/2 and 7/2. Or in other words, x minus 3 had to be less than 1/2. So we actually know that the radius of convergence is 1/2. Right? Radius of convergence is 1/2. Okay, so that's what we get from that. And now, because we're a half a unit above and below 3, so above and below the center. So the radius is 1/2. Now the question is, will it converge at 5/2? Will it converge at 7/2? Well, we have to test those individually. So what that means is we have to go into the original formula and replace x with 2.5 and see what happens, and replace x with 3.5 and see what happens. So that's another thing we have to test individually. So let's do that. X equals 5/2 or 2.5. So we go into our series. It would be the series. Now the formula is 2 to the k. So 2 to the k times x minus 3 to the k. So 2.5 or 5/2 minus 3 would be a negative 0.5 to the k. And then that's all divided by k. And so we simplify. We get the sum of 2 to the k over k. And 0.5, negative 0.5 to the k would be negative 1 over 2 to the k. So we can rewrite that as the sum of 2 to the k over k times minus 1 to the k over 2 to the k. So of course the 2 to the k's will cancel out, and so we would get the sum of minus 1 to the k over k. That's going to be our series when kx is equal to 5/2. We know that series converges because it's an alternating series, and it's actually the alternating harmonic series, so we know it converges because of that. But also, if you'd forgotten exactly what it was, that's okay, because we know it converges because it's an alternating series and the limit of the underlying sequence goes to 0. And that's actually a decreasing sequence, right? 1 over k decreases. So therefore it converges. So at x equals 5/2, it converges. What about at 3/2? Well, at 3.5, when you plug x equals 3.5 or 7/2 in, then this would be, going back to the original, 2 to the k. 3.5 minus 3 would be a positive 1/2. So we're going to have 2 to the k times 1/2 to the k over k. So rewriting that, we would have 2 to the k over k, just like we had here, and then b times positive 1/2 to the k, which would be the same as 1 over 2 to the k. And so, of course, because 1 to the k would just be 1, and so that's just going to be the series of 1 over k, which we know that one diverges because that is the harmonic series. In a couple other ways you could say that. It diverges because of p-series. It's 1 over k to the p. K is not greater than 1, so it diverges. K is less than or equal to 1. P-series, it diverges. So at 3/2 it doesn't work. So putting the question together then, the radius of convergence 1/2, the interval of convergence, this converges at 2.5 or 5/2. But it diverges at 3.5. Right? And so therefore, we have our problem there. Right? Our series only converges for x between 2.5 and 3.5. Any other x values, this series will diverge. But if you're in that interval, it will converge. It will converge. Now, one of the things we're not really dealing with here, that we're not knowing how to handle, is what does it converge to, though? Right? These converge. I've said these two problems both converge. But what does it converge to? Right? What does it converge to? That's really not a question we're equipped to answer yet. We will be able to do a little bit of that, but much more, we'll be able to do a little bit about what some series will converge to, because we'll be able to recognize them as a certain as a certain series that we know the convergence of a little later. But a lot of it is going to be beyond our scope. Okay, a lot of the convergence will end up being beyond our scope. But we will at least be able to talk about whether it converges. We might not be able to talk about what it converges to, but we can at least talk about when it converges.